Hello, I'm going to talk to you today about chi-squared. So the objectives of today's lesson are to find out how to use this chi-squared equation and how to interpret the results that we've got from that. So we're going to think about what that chi-squared is used for. Chi-squared then is a statistical test that's used to find out if there's a difference between observed and expected data. And quite often in biology we would work out the expected using some kind of strong biological theory. So the best application of this chi-squared is for genetics. So we will come back to it again next year where we can actually use this chi-squared for our genetics. But today we're going to be using it for a slightly different one. I'm just going to go through an example which is related to your current topic that we're looking at for the biodiversity. You'll always get given this formula. You just need to know how to actually use the formula. So that's what I'm going to go through today, step by step, how to use this formula. So the example that we've got is we're looking at a woodland area and we've got some expected values just here, and we've got observed values of the frequency of each of these different plants in a particular area. And that's what we're going to be looking at. We're going to be looking to see whether there is a significant difference between what we expected to find in that area and what we did actually find in that particular area. So first of all, we need a null hypothesis. So here, the null hypothesis is that there is no statistically significant difference between the observed and the expected number of plant species. And so I've got my step-by-step here. Now with any formula, you need to do things in the correct order. We call it the order of operations. So we're going to start off with the brackets here. So step one then is observed minus expected. And then we're going to square that. So observed minus expected squared is step two. Then we're going to divide that by expected. That's the step three. And then we're going to add all of those together. So on the bottom here, you can see I've put a table in and I've got some columns here that I've added on. Now, often in an exam, they won't give you those columns. So it's really useful to remember the what I've got in each of these columns. So the first column then is for step one, the observed minus expected. You can see I've color-coded that in red. So observed minus expected will go in here. The second column then is for the observed minus expected squared, so step two, and I've colour-coded that blue. And then it's observed minus expected squared divided by expected, and I've colour-coded that in green. And then finally adding all of those together, and I've colour-coded that in purple, so that's step four, and I've colour-coded that in purple. So this is a really useful thing to remember what is in each of those columns. Step one then is observed minus expected. So you can see here I've done the first one. So we've done 5 minus 10, which gives you minus 5. And I've done that for each of these then. So we've got each of these values by doing observed minus the expected there. Step two then. Observed minus expected squared. So I've squared each of these figures. So minus 5 squared is 25, and 12 squared 144, 3 squared 9, etc. Then I've divided it by the expected there. So 25 divided by the expected, which is 10 here, gives you 2.5, and I've done that for each of these different plants. And then I've added it all together. So we get our sum of, and that gives us a chi-squared value of 15.22. But what does this mean? So we're going to think about what it means. Now, what we're going to be doing, as we've done before, is compare it to a table of critical values. So we had 5 different plant species, so 5 categories, minus 1 gives us 4 degrees of freedom. So our critical values then are 9.488 and 13.277. And again, we're going to be using this MRSA. So if the calculated value for chi-squared is more than the critical value, then we reject the null hypothesis. And if the calculated chi-square value is smaller than the critical value, then we're going to accept the null hypothesis. So if we think about the data that we've got, we managed to get a calculated value of 15.22. So because our chi-squared value, 15.22, is much greater than the critical value, we're going to reject the null hypothesis at that 5% significance level. So we are 95% confident then that there is a significant difference between the observed and the expected results that we've got there. Good. Okay, I'm just going to go back to the step-by-step. Use this step-by-step to help you to have a go at some of the questions that I've set for you. And if you get stuck at any point, contact me via email or on Teams. Good luck. Enjoy.